Welcome to Finding Stuff Out. The show is simple. You ask, I find out. It's not rocket science, unless you ask a question about rockets. Then it is. Here's today's first question. It's from Joy.
How come weather just changes to other weather, like first it's hot, then it's cold?
Yeah, what gives? Weather's always changing and I don't know why. But by the end of the show, I'll have the answer to your question. Along the way, though, there'll be tornadoes, snow, hail, and if my dad doesn't fix the washing machine soon, maybe even a flood. I'm going to start the investigation with the question from Hanifa.
How could the sun be out in winter when it's cold?
Yeah, come on, son. Either you're hot or you're not. Pick a side. Pretend this light bulb is the sun. Now, lucky for you guys, I did some research on the subject. Now pretend this is the Earth, us. The Earth orbits around the sun. The sun feels hotter in the summer because the part of the Earth you live on is tilted toward the sun. 6 months later, when the Earth has moved around to the other part of the sun, the part you live on is tilted away from the sun. So we can still see it, but we're not getting the full effects of the sun's rays. So it's not as hot. Next question.
How many kinds of snowflakes are there?
How many different ones? Let's see. They say no two snowflakes are alike. And they're only this big. I wonder how many fit in a teaspoon. Must be hundreds. But when it snows, there's so many of these, you need a shovel to clear a path. That must be millions. And then you need a snowplow to clear your street. There must be billions, or trillions, or bajillions, or gazillions, or whatever they call a number that high, and... You're gonna make my head explode! I don't know if bajillion's a number, but there must be a bajillion different snowflakes out there. But seriously, nobody knows how many different snowflakes there are. But I can show you some of them up close with my super zoom-o-matic. Check out these snowflakes. They all sort of have 6 sides. Weird. I'm not sure if they're different or the same though. So let's see. Different, same. Oh wait, no, different. Forget it. I'd rather look at a bajillion snowflakes all at once than each flake one at a time, because that would mean snow day! Though I'm with Elizabeth on the next question.
Why can't it just be sunny all the time?
That would be amazing, Elizabeth. To figure it out, please welcome my special guest, TV weatherman, Frank Cavallaro.
Hey, Harrison, how's it going?
Hi, Frank. Welcome to my show.
Nice to be here.
Now, did you bring your thunder for the interview today?
No, but I got something else for you.
Oh.
Some snow.
Okay, so could we have sun all the time?
I don't think so, because there's always going to be some cloud cover around, so therefore it'll block the sun's rays.
So no permanent sun?
Actually, that's a good question. You know, there's going to be a time every year, I'm going to use the globe here, there's going to be a time every year for 6 months where the North Pole, as the Earth rotates, will have daylight for 6 months.
Well, I'm just going to move there.
No, hold on now. It doesn't mean it's going to be hot. But look at what happens 6 months later. The South Pole will get the sun, and the North Pole is dark for 6 months as the Earth rotates.
Living in darkness? I'll leave that to the mushrooms. Anyway, here's a question from Shakur.
My question is, why is there wind?
The short answer is 3 being chilly. But seriously, I found out that the sun causes wind. The sun heats up the land and the air, which causes hot air to rise. Then cold air zooms in to take its place. Hey, I should make a song about this. It could be a rap. Hit it! Yo, yo, hot air goes up, cold air goes down. That's when we feel wind on the ground. It blows around leaves and sticks and twigs. It even blows off my grandpa's wig. Land heats fast and water slow. That changes how the wind will blow.
Yeah, wind will go just where it needs because air heats up at different speeds.
All this talk about wind takes my breath away. Hey, that reminds me, I can make my own wind. See? Wind. You can measure the direction and the speed of the wind using something called a windsock. Frank will show us.
Uh-oh. Do try this at home.
Here, I brought this sock for you, Frank.
We're not here to measure smell. We're here to measure wind.
Well, I think you can also do it with a paper bag, so you can try this at home. Here, show us.
Okay, let's try this. I'm going to use a fan in this paper bag. This is a light breeze. Anything over 10, 11 kilometers an hour is a light breeze. But watch what happens if we get a gust of strong winds.
Whoa, it opened right up.
And this could cause damage to branches, trees, roofs, and your hair.
Not my hair. Yeah.
Yeah, your hair. So Harrison, you may have noticed that airports and helipads, they have these windsocks there. You know what they do?
Yeah, are they those orange things, right? I don't know what they are, though. What they do, I mean.
Well, most planes will land and take off against the wind.
Okay. So that means?
That means that they look at the windsock, and that tells them which runway to use as they're approaching the airport.
So a windsock is the airport's version of our paper bag.
That's right.
So I guess if a plane is landing, they'd be facing that way, right?
That's right.
They'd come down. Meow. Okay, so what can kids use this bag for outside?
Well, you can actually go in your backyard and take out a bag on a windy day and put up the bag, and it'll tell you how strong the winds are.
And which direction,
And
right?
which direction. And if there's no wind, then look what happens to the bag. It just dies.
Well, Frank, I just thought of another thing you can do with the paper windsock.
What's that?
Well, if you blow it up with air, and then you can make thunder. Here's another question. It's from Ben.
Where do clouds come from?
I looked it up, Ben, and I made this animation to show you where clouds come from.
So these water vapors in the air grab onto a piece of dust. And when a billion of their buddies do the same thing, we start to see them together as a cloud. The air up there is colder, so the cold air causes the water to condense. Then these drops crowd together like it's a huge party and start bumping into each other. As the droplets bump together, they form bigger and bigger droplets, and then when they're too heavy to float in the sky, they fall as rain. Here's a question from Chloe.
How do weather people know if it's gonna be sunny or not?
The Flat Earth Corner!
How does a weatherman in ancient Babylon know if it's going to be sunny or not tomorrow? Astrology, of course. If I look up in the heavens, I can see that the moon is in Virgo, in the 4th house. Jupiter is rising. That means I predict you're going to get good news, win friends, and influence poultry. Also, it's going to be sunny and mild. Mars is activating my 2nd solar house. This can't be happening! Maybe I should have dissected a chicken instead. In ancient times, people used to use the stars and the planets to try to predict the weather. But it didn't always work out. So now we have high-tech equipment that helps us predict the weather accurately. Well, most of the time. Right, Frank?
Yeah.
I guess that's a sensitive topic for you. I mean, how do you predict the weather? Do you flip a coin?
No. We use radar, satellite, we have different data, computer models that show us the jet stream, the wind, systems that are developing. We put everything together, and that's how your forecast comes out.
How come with all this high-tech equipment, you still get the weather wrong sometimes?
Well, Harrison, you know, Mother Nature's always full of surprises. The weather can change drastically very quickly.
How can the weather change so fast?
Things happen. The winds change direction, brings in colder air, temperatures drop, then the warmer air comes in, temperature goes up. It happens.
Wouldn't you be able to see the wind changing directions and stuff with all your fancy high-tech equipment?
And most of the time we do, but there are exceptions to the case where sometimes the weather just changes drastically that the computer did not pick up. But we're getting a lot better. We now have long-range forecasts. We can tell you the weather 6, 7, 8 days down the road. But I got to tell you, it's tough to do the weather sometimes, but it's fun presenting it.
Well, let's see how hard Frank's job really is with... Today, my contestants are Justin and Samantha. So today, you're going to be using your knowledge of wind, clouds, and forecasting to become TV weather forecasters. Think you can do it?
Yeah.
Okay then, Frank, please tell us how you do your job on TV.
Okay, guys, follow me. So this is where it all happens, guys.
It's all green in here.
Frank says he stands in front of a green wall when he presents the weather on TV. That's because there's a technical process that takes all the green out of the picture so he can put any kind of background behind us. Like this, this, or if you're a TV weather person, a map.
This is a clicker, by the way. Every time I press on this, a different map goes on. It could be a radar, a satellite, whatever I want to show. This advances my map, so it's all computerized.
So let's show the kids at home. They see a map behind us right now, right?
That's right. They see a map, and when I click, the map will change. And you point.
Okay, let's do the challenge. Here's a map of the world. I'm going to be telling you different weather conditions, and your mission is to try and predict the weather and where it will occur. Now, there are 5 different weather icons: sun, snow, rain, cloud, and wind.
And I'll be asking you where to place the specific icon to a corresponding city. But here's the catch. The viewers at home will see the map. You won't see the map. You're going to have to use that monitor.
It's just like how Frank does his weather forecast. Your goal is to make as few mistakes as possible.
Okay, Samantha, you're up first. Justin, you can go downstairs and have some milk and cookies with my mom.
Yes, I got the fresh ones.
Leave some for us, though.
Maybe.
Okay, are you ready?
Yeah.
Okay, first question. Water droplets have formed giant heavy clouds over London. What's going to happen?
Oh, Samantha's going for the rain icon. Not wasting any time.
Yeah, that's it. Good job. Okay.
Next question. The hot air over Thunder Bay is rising and cold air is moving in. Go.
Samantha's grabbed the wind icon. Oh, she's close. Not quite. Yes, she's got it.
Okay. Treble cone is in the southern hemisphere, and it's July.
Well, Samantha's found the southern hemisphere, but can't seem to locate treble cone. And is that the right icon?
No,
That's not it.
not right.
That one's a little hard.
What happens in the northern hemisphere in July?
It becomes hot.
What happens in the southern hemisphere in July?
It becomes cold. Oh.
There you
That's
go.
correct. It's snowing.
Okay. Water vapor is condensing over Beijing. Go ahead.
Samantha's going for the rain icon again.
No,
I'll read the question again. Water vapor is condensing over Beijing. What's happening?
Clouds.
There you
There you
go.
go, perfect. And that's it. Okay, Samantha, you're done. We'll send you downstairs for some milk and cookies, and now we'll bring Justin up and see how he does. Okay, Justin, now you're up. The first question is, water droplets have formed giant heavy clouds over London. What's going to happen?
Justin wastes no time in grabbing the rain icon.
That's right.
Next question. The hot air over Thunder Bay is rising and cold air is moving in. Go.
Justin's checking out the monitor to see where Thunder Bay is.
No. Yep, there you go. That's it. Okay, treble cone is in the southern hemisphere, and it's July.
Justin also going straight for the sun.
No,
Wrong icon.
nope.
Listen to the question carefully.
Treble cone is in the southern hemisphere. It's July.
Justin's going for the rain icon. Oh, but he changes his mind.
There you go, that's it.
Final question. Water vapor is condensing over Beijing. What's it going to be?
Justin's got the cloud icon, but where's Beijing? And Justin's found it!
All right.
And now we'll get Samantha and announce the winner. Samantha, you can come up now. Okay, and the winner is Justin!
Yes.
Good job.
Congratulations.
Good job, guys.
Thank you.
Thank you.
And now we have a question from Max.
Why are tornadoes dangerous if they're just air?
Yeah, how is air dangerous? I mean, I can just push it with my hands.
Well, Harrison, air could be dangerous. When the pressure starts going up and down drastically in a short period of time, it can cause some serious damage. I want to do a little demonstration on a tornado.
Okay.
And of course, tornadoes can cause some serious damage, as we all know. Look at that. The wind speed of tornadoes sometimes could hit over 400 kilometers an hour, over 250 miles an hour.
Whoa.
And the thing with tornadoes, they don't give you a lot of time to get away. They just pop up because the pressure goes down, the pressure goes up, and this is what happens. And that's why tornadoes are very, very dangerous.
That's crazy. Now to find out how dangerous tornadoes really are, let's talk to George Coronas, who's a real live storm chaser. He's out chasing storms as we speak. Hello, George. I see you're out in some terrible weather. You could catch a cold out there, you know?
Harrison, as a storm chaser, catching a cold is the least of my worries.
So first of all, I think the kids at home probably want to know, what is a storm chaser?
Well, what I do is I try to get up close to the most dangerous part of the storm and then send in my reports so that people downstream of the storm can get those reports and hopefully save a few lives.
That sounds pretty risky. Why are tornadoes so dangerous?
Well, it certainly can be dangerous. It's not so much that the wind is blowing, it's what the wind is blowing. Pieces of debris, which could be branches, bricks, cars, sometimes even houses.
Wow.
So have you ever been inside of a tornado?
I have actually been inside a tornado once before with debris flying around. It's a very, very scary experience, one that I don't want to do again.
How'd you end up being right inside of a tornado and stuff?
Well, sometimes a tornado will change its path. I'll be tracking the storm and it will change direction, and sometimes I have to get out of the way. It's a force of nature. It can be very unpredictable at times.
So what technology do you use to help you chase?
Well, I've got all kinds of technology here in my storm chase vehicle. I've got my laptop computer that has satellite and radar imagery. I've got all my radios that I can use to send my reports in to the National Weather Service. GPS, all kinds of gadgets. It's basically a mobile command center on wheels.
So I'm pretty sure everybody watching wants to know, where do you go to the bathroom when you're chasing storms?
When you're on a storm, Harrison, anywhere you can. Anywhere you can.
That's a little awkward.
Sometimes it is. There's not a lot of trees out in Kansas, so you just have to find a place, and it's not always easy.
Do you get any adrenaline going when you're chasing the storms?
Absolutely, it's a bit of an adrenaline rush, especially when you're up close to a tornado, when the wind speed can be several hundreds of kilometers per hour. I'd be lying if I didn't say that I got some kind of adrenaline rush out of it.
Do you have to ever, drive away or, run away from storms or tornadoes?
There's been numerous times where I've had to get out of the path of a tornado to turn tail and flee. I try to do a dangerous thing in as safe a manner as possible.
Yeah.
Oh, looking at the radar right now, it looks like I might have a developing tornado on the horizon.
Are you gonna go out and chase that right now?
Yeah, it looks like I'm gonna have to blast west here. I have a developing tornado.
Wow.
Hold on, let me get the radio here. Yeah, this is George K. relaying a message. It looks like we might have a tornado forming just to my west. I'm gonna try and intercept and get closer. Harrison, I gotta go.
Well, thanks for being on the show, George. It was great to have you, and I guess you have to go chase this storm.
Okay, I'm headed straight for the tornado. Stay in touch.
Okay, be safe. Bye. Whew. George sure does love his scary weather. Speaking of scary weather, here's a question from Samantha.
Why does hail hurt so much?
Ah, hail. The snowball's angry cousin. Usually a raindrop grows until it's too heavy, and then it will fall to the ground. Matter of fact, let's check back in with my buddy, the raindrop.
Hail is created when the raindrops, instead of falling down, get blown further up to colder air. The raindrops freeze into ice, get bounced around by the wind, and get bigger and bigger until they get too heavy and fall.
This means that instead of having a gentle drop of rain, you have a painful ball of ice. Ah! It's like waking up in the middle of a snowball fight. Watch these clips that George sent us.
On George's last storm chase in Nebraska, he found hailstones as big as baseballs.
Man, weather is no joke. I've found out a lot about weather, so I think it's time to answer
Joy's question that started today's episode.
How come weather just changes to other weather? Like first it's hot, then it's cold.
The big answer is... there's lots of reasons.
The tilting of the Earth changes the seasons. Wind blows when the sun heats up the air. Water vapor forms clouds, and clouds block the sun.
But there's no clouds here today, so I'm gonna go outside and enjoy the beautiful day. See you next time for more Finding Stuff Out.
Brr, it's chilly here. I've been thinking a lot about cold today. Because I saw a movie where scientists found a frozen caveman and brought him back to life. It made me wonder the same question as Justin.
Is it possible to freeze myself and come back to life?
Wouldn't that be cool? But it seems impossible. My frozen fish sticks aren't coming back to life, right? But I started checking, and I found something shocking. This frog was frozen solid in the winter. It was so frozen that if you were to move its legs, they would snap off. There's no way this frog could be still alive, right? But it was! When it thawed out, it was as good as new. What? That's impossible. They were frozen solid. That's almost as crazy as my fish stick coming back to life. What's all the excitement about? Some things that seem impossible are actually true. I found out that some frogs, bugs, and even turtles can survive being frozen. But I didn't find any big animals or people that can do that. So I don't know the answer yet to Justin's question. But I promise I'll find out by the end of the show. Maybe your questions about cold will help me.
Why do you get a brain freeze when you drink something very cold?
Well, Maya, I don't know if I can freeze my body, but I know I can freeze my brain. Ah! Maybe that was unwise. How do you do that?
Hey, chill out. I'll show you.
You want to know why I cause you pain? Near the top of your mouth, there's a tube to your brain. It takes blood right up to your brain. This tube is called an artery. It's really very smartery. When your mouth is too cold, it yells cold overload, pushing warm blood to your brain, and that's what causes pain. So don't you do it again. Now that you know, you should drink me slowly. Yeah!
Is there such thing as the abominable snowman?
Well, Raphael, I know a girl who lives in the Arctic where there's a lot of snow. Let's ask her. Hi, Kylie. I'm just wondering, have you ever seen an abominable snowman?
Oh yeah, I've seen one before.
You have? What did it look like?
It was really big.
Whoa, when did you see it?
And Halloween?
Halloween?
Yeah.
Kylie tricked me. But some people really do think they've seen an abominable snowman. In the Himalayan mountains in Asia, they call it a yeti. A flat earth corner! I saw the abominable snowman with my own eyes. Buy a ticket to see for yourself. I'll guide you up the mountain if you dare. I even took a picture to prove it's real. Okay, so the picture doesn't do it justice. But for just $5, you can see the Yeti with your own eyes. The abominable snowman, or Yeti, whatever you call it, is just a myth. People who think they've seen it probably just saw bears. But I found another explanation. People in the mountains sometimes see shadowy figures and think it's the abominable snowman, but it's actually an optical illusion. When you're high up in the mountains and the sun's behind you, you can see your own shadow in the clouds. Ah! Ah! You're saying I was scared of my own shadow? Well, what about this footprints I saw? Huh? What do you say about that? I need an answer. Whoa! I've seen that same footprint right here in the attic. Just kidding. But some people have seen huge footprints in the mountains, like this one. I wonder if something else besides a Yeti could have made them. Maxim and Kiana are going to help me find out. I printed out some other tracks that we do know. A grizzly bear's front and rear paws, a black bear track, a wolf track, and a human boot track. Let's see if our detectives can find a match and solve the mystery.
So that's a Yeti paw.
I think we should try on some of the tracks on the Yeti paw to see which one's the more similar.
Okay, let's try that one first.
The grizzly bear's front paw.
That kind of looks similar. There's still some differences.
Yeah, it's not long enough, though the front part seems to fit.
Let's try this one.
Okay.
The black bear paw.
No.
I don't think that fits.
What about the wolf paw? Nope. The human boot?
No.
None of those prints look exactly like the Yeti print.
Maybe we should put this and put another bear paw just to make sure. It doesn't have to be perfect.
Smart. They're using both the front and the rear bear paw to make it fit.
Yeah, I think this is it. It's big enough.
It's wider.
I think it's good.
That makes sense. If a bear makes a print with his front paws, then steps just behind it with his back paws, the combination looks like a giant footprint. That's probably what fools people. Thanks, detectives. So, to answer the question...
Is there such thing as the abominable snowman?
Well, from what I can see, there's no proof it exists. Aww. Psst. Hey, Zoe. You're ruining my ticket business. Don't you have another question to answer? Come on.
Do Inuit really live in igloos?
I checked, and Inuit now live in modern houses. They also use modern snowmobiles to get around. But the Inuit invented all kinds of things that made life possible in the far north. The Inuit invented snow boots.
These are gummets, and they help keep our feet warm, and they help us keep up on the snow instead of sinking.
Here's something else.
Did you know that Inuit invented the kayak?
That's right. The Inuit invented the kayak, a kind of boat that can travel through icy water. They also invented goggles. And they even invented dog sleds, which were the fastest and furriest way to get around the Arctic before snowmobiles. But the igloo was the Inuits' most famous invention. Outside temperatures can get as low as minus 45 degrees Celsius. But inside an igloo, it can warm up to 16 degrees Celsius with just our body heat. Ah, it's so cold. I want to be in an igloo. An igloo is a smart way to stay warm. I think I'm going to ask my friends how they stay warm.
Ask a friend. I would make a pile of snow, and then I would make a kind of like a dent inside, and I would probably lay in it.
I put many layers of clothes. First I put tights, then I put my normal pants. Then I put a third layer of splash pants.
I would keep my body active so I keep warm.
Bring a bowl of soup with me outside and eat it because soup is hot, so it could warm you up.
Put on a jacket, like 4 sweaters. I would go inside my house.
Those are all great ideas, but I think you need some expert help. It's too late. No, it isn't. She works in the Arctic where it's cold and Arctic, and the seals like to Barctic. Please welcome Fantastarctic, Marianne Bernardo.
Hi, Zoe.
Hi. I didn't know you were bringing a friend. Nice to... Where's his hand? So, do you really work in the North Pole?
Yeah, I do research in the Arctic to understand how climate is changing the ways animals and people live and get food in the extreme north.
What's the coldest you've ever been?
I think it was about minus 30 degrees, but it was very, very windy. That's why I wear a special suit that's even warmer than a regular coat. It can go about at minus 40 degrees, I think.
Yeah, it's really thick. It must be warm.
Oh yeah, it's really warm. It has a lot of insulation, which means that it keeps the warmth of your body inside the coat and keeps the cold air outside.
Yeah, I definitely want to wear one of these if I was in the coldest place. But here's a question from Chelsea.
How do animals stay warm in winter?
Yeah, what do animals do in the cold? They can't just buy a coat.
I wonder if it comes in pink.
I checked, and some animals obviously have built-in fur coats, and sheep have wool coats in the winter. In the summer, ranchers shave off the wool so the sheep don't get too hot. We use the wool to make sweaters and blankets to keep us warm.
Woohoo! Win-win!
Birds keep warm with their feathers and fuzzy stuff called down, which we sometimes use to make comforters and jackets. But I noticed something about animals who live in really cold places.
Yeah, what's that?
They have a lot of fat on them. Does fat have something to do with staying warm?
Yes, warm-blooded animals have to keep their bodies at a constant temperature. So many Arctic animals have what's called blubber, a kind of fat that insulates their core. It's sort of like what my cold weather suit does.
I've worn a wool coat and a down coat, but I've never worn a blubber coat. That gives me an idea for... my great challenge! My challengers today are Ruby. Hi. And Jaden. Hi. Are you ready for a very icy challenge?
Yeah.
Yeah, I'm ready.
Okay, imagine you're seals in the Arctic, and you're trying to catch fish in icy water. It's so cold, I can barely put my hand in it. Your challenge is to reach into the icy water and grab as many fish as you can in 60 seconds. But don't worry, you're seals, so you have a blubber coat. Marianne will show you how.
So first, you have to dip your forearm into this tub of shortening.
The shortening acts like the seal's blubber. Pretty squishy, huh?
So weird. It feels so, like, slimy.
And now, just like seals, you need some skin to hold that blubber together. So let me help you put that on.
That glove's also full of blubber.
There you go.
This is so weird. Whoa.
Okay. Now the skin.
Is it slimy?
Yeah.
Okay, time to go diving in the icy water. Remember, the one who gets the most fish wins. On your mark, get set, fishing!
There's one. Come on.
Go! Find them!
That's nice. One. There's another one.
Only 12 seconds left, and it's tied up at 3-all. 4-3 for Ruby.
One more.
Jaden ties it up with 5 seconds left. Ruby gets one. Jaden reaching for a fish. Okay, time's up. Jaden, you have 1, 2, 3, and 4. Ruby, you have 1, 2, 3, 4, 5. Okay, so Ruby, you're the winner. Woo! Okay, so I want you both to put your other hand in and tell me the difference.
Okay.
Oh,
That's way colder.
Yeah, that's because on the right hand, you have the blubber like a seal.
Yep.
And on the left hand, you're a human.
Right.
Okay, because you guys were such great seals, your reward is you get to keep the fish. Ryan had a question about animals without blubber.
How do fish live under the ice? It must be cold there.
Yeah, good question. Fish don't have blubber. How can they not freeze under the ice?
In the cold, fish can slow down their body's functions, so they use less energy.
That's like a video I saw about frogs and how they freeze.
Yes, frogs can do that because they are well adapted to their environment. So are Arctic animals. We've learned about marine mammals that have a thick layer of blubber so that they can live in the Arctic. And then Arctic fish can survive in extremely cold temperatures.
Oh, so could we humans slow our bodies down? Could I freeze myself in the winter and come back later like a frog?
No, humans aren't adapted to do that. You know how you shiver when you're cold? It's your body working hard to try to stay warm. In really cold places, your body tries to keep its core warm, and then your fingers and toes are extra vulnerable to frostbite. We could die in extreme cold.
It's not looking good for Justin's question about how we can freeze ourselves and come back in the future. But I'll keep checking. Thanks for helping me find stuff out, Marianne.
My pleasure.
Marianne said we can't freeze ourselves in the snow and thaw again like frogs. But what if we had a super techno freezing machine? Let's find out. Hi, Don.
Hi, Zoe.
I'm here to see your high-tech freezing machine.
Okay, but we're gonna have to get dressed up first.
Okay.
Let's go.
I'm at the National Research Council's climate chamber, where they can make it as cold as Antarctica. Wow, it was so hot outside, but it's so cold in here.
This is our climate chamber.
It's basically like a giant refrigerator. What do you use it for?
Oh, we use it for all kinds of things. We test trucks and trains and tents to keep people warm in the winter. Anything that's outside, we can test it inside.
Cool.
Very cool.
Woo! It's winter again! Woo! Whoops. Sorry. Having too much fun. But here's a question from Dario.
Is the South Pole colder than my freezer?
Oh, the South Pole is much colder than your freezer. It can get as low as minus 89 degrees C at the South Pole. Your freezer's probably only minus 20, so it's very much colder at the South Pole.
Well, I guess at the South Pole, a freezer would be a good place to warm up. On weather reports, I see something called the wind chill. What does that mean?
When the wind is blowing, it takes heat away from your body, so it makes it feel much colder than the real temperature.
How big a difference is it?
We could find out if you like. We have a big fan.
I think you mean a ginormous fan. It was so cold in here before, but now it's even colder. It feels even colder.
It does.
I don't think I've ever felt colder cold than that.
That felt like minus 65 degrees C. It was only really minus 30 degrees C, so that's 35 degrees colder with the wind.
It was like we really were at the South Pole. I could really use a hot chocolate now. Hey, what would happen if you took hot chocolate and put it in the climate chamber? Would it turn into instant ice cream? Some of my friends did an experiment like that. They live in Nunavut, where it's seriously cold in the winter.
2, 3, throw.
Whoa! So cold that if you throw hot water, it freezes before it hits the ground. Pretty cool, huh? Think we can try something like that?
Let's go try it. Ready, set.
Wow! The water froze in midair.
That's pretty cool, isn't it?
That is pretty cool. That was awesome. Being a scientist looks like a really cool job. But now, let's answer Michael's question about freezing stuff.
How cold would it have to be to freeze a ball of iron all the way through so that when you drop it, it shatters?
Okay, so gummy bears aren't exactly iron, but we're gonna see what happens when they get frozen solid.
First, let's see what happens when we hit one that's at room temperature.
It just got squishier.
It's just a little bit dented.
I wonder if the frozen one will be different.
Let's try it.
Yup, that one's frozen solid. It shattered into 1,000,000 pieces.
So, when the gummy gets really cold, it turns almost into glass. The molecules stick together just like the molecules in glass. So when we hit it, it breaks just like glass.
Interesting. But could you freeze an iron ball so cold that it shatters?
You could, but it'd be pretty hard. Iron balls are made to be strong.
Uh-oh, do try this at home. Want to see for yourself how cold changes things? Take 2 identical rubber balls, or tennis balls. Put one in the freezer, one someplace warm. The next day, see how differently they bounce. Check this out. The frozen one hardly bounces at all. Let's see that again in slow motion. Exact same kind of tennis ball, but when it's frozen, it loses its bounce.
But what would happen if people were frozen solid? Have you ever tested that?
That would be a very bad idea. We don't have the technology for that just yet. The water in their cells would freeze. That would kill them.
Yikes. Well, thanks for helping me find stuff out.
You're welcome.
And that takes us back to Justin's question that warmed up my show. Is it possible to freeze myself and come back to life? The big answer is... no. We can't freeze ourselves for the future just yet. We die from just being frozen. But maybe that's why people have invented ways to stay warm and survive in the cold. We invented clothing that keeps us warm in extreme cold. The Inuit invented igloo shelters and ways to get around in cold places. We learned to build big buildings that protect us from winter weather. We even have climate chambers to test how our cars and machines will work in the cold. We humans are pretty smart. Cold may be dangerous for us, but we've invented all sorts of ways to outsmart it. I shall defeat you! Okay, maybe some things the human mind just can't solve yet. Ow! Oh, see you next time for more Finding Stuff Out.
Hi, welcome to Finding Stuff Out. I'm just getting over a sore throat, and gargling with salt water seems to help. It's like having my own little ocean. Speaking of that, here's a question from Vito.
Are sea monsters real?
The Flat Earth Corner! Are sea monsters real? Well, Landlubber, if you're a 16th century sea dog like me, you know they are. I haven't seen one myself, but my best friend's captain's daughter has, like the Kraken. A Kraken wraps its giant tentacles around a ship and eats every last sailor down to the bone. Then there's the Greenland sea serpent, its ferocious head taller than a ship's crow's nest. And the sea orb that can gobble up an entire vessel and its crew. Scary enough to have you running for the poop deck. Yes, the sea is full of monsters. Just ask my first mate's brother's neighbor's midshipman who knows somebody that got scuppered up by one. Ah! Hundreds of years ago, sailors saw strange things in the sea and thought that they were sea monsters. Today we know that the Kraken was probably just a giant squid, but pictures of a living giant squid were taken only a few years ago. The ocean is so big. We still don't know all the creatures that live down there, but I can confirm for you, Vito, that there is at least one sea monster. Today, I'm gonna answer all your questions about the ocean, and by the end of the show, I'll show you that monster. Street Smarts! Whenever I'm at the sea aquarium, there's always one question I want to find out. So, do you guys think that sea monsters are real?
No. No. Yes. Not really.
So, do you think sea monsters are real?
No.
What about your bathtub? There's sea monsters in there, right?
No.
If they did exist, what do you think they would look like?
Well, it could be green or maybe gray from the water it's been in and the pollution. A big blob, yeah.
A big blob?
A dark color, like green or black, and have sharp teeth.
Sharp teeth. That's pretty scary. So what do you think a sea monster would sound like? That's pretty good.
Yep.
Nice.
Personally, I think the sea monster would look something like this. Scary. Time for another question.
Why is the ocean salty?
The short answer is because there's salt in it. I kid. But you're probably wondering how the salt got in there. And it turns out the ocean doesn't start out salty. Here's what I found out. Ah, beautiful clear spring water. Flows down from the lakes and the rivers down to the ocean. I like to think of it as clear juice.
On its trip to the ocean, water moves over soil and rocks, which have salt in them. The water drags the salt into the ocean.
Say this glass of water was the ocean. Then it has this much salt in it. That might not sound like a lot, but if you take all the salt out of the ocean, it will cover the earth up to the height of a 40-story building.
Wow.
With all the salt in this water, you might be wondering, who'd drink this stuff? But that's exactly what Dakota wants to find out.
How do fish drink?
To find out more about fish and how they drink, please welcome my special guest biologist, Dr. Adam Brown.
Hey, Arcee.
Hi.
How you doing?
Good.
So I hear you want to know how fish drink.
Yeah, I asked my fish how he drank, but he just said...
So I guess you don't really speak fish then.
No, not really. So how do fish drink? Is it out of a straw or a glass?
Well, actually, fish don't really drink in the same way that we do.
Okay.
Mostly because they're bathing in water, right? So water either moves in or out of them on its own, and that's a process that we call osmosis.
Okay.
Which basically means that water tends to move towards areas that are saltier. And so, depending on where the fish will live in the world, it'll either always have to take on water or always have to get rid of water.
So can you show us how all this works?
Well, yeah, exactly. I've got a great example for this using a simple potato.
The experiment!
So what I've done is I've cut up some potato slices here that are going to be our sort of pretend fish. And I'm going to put these pretend fish into the two types of water that we have on Earth, salt water and fresh water.
Okay.
Right?
I think I have just the thing.
Okay.
That's not it. Oh, not that again. Oh, here it is. Okay. So we can have potato fish.
All right, let's make some potato fish here.
It's a new species of fish called potato fish.
Yeah. There we go. Potato fish
Number
one will be in the ocean.
Okay.
And potato fish number two.
He gets to be in fresh water.
That's right. Okay, so let's put the salt water here on the ocean fish.
Okay.
Let's put the fresh water here in the lake or the river fish.
Okay. So what's going to happen to these potato fish?
Well, remember I said that water moves in and out of organisms on its own based on osmosis, and it always goes to where it's saltier, right? Well, here what we have is a potato fish in salty water. So that potato fish is less salty than the water around it, meaning the water is going to move out of the potato fish into the salt water. And here what we have is the potato fish is in fresh water. It is actually saltier than the water around it.
So the water's going to
The water's going to move in. That's what we expect to happen.
So what you're saying is...
If the saltwater fish didn't drink, it would shrivel up.
Ah, there's the stuff.
And freshwater fish absorb all the water that they need. So if they drank any more, they'd pee a lot.
Well, yeah, that's exactly right. Either they pee a lot or they're going to end up exploding with all of that water in there.
So how are the potatoes doing?
Well, they're not quite ready. We still have to wait a little.
I hate waiting. I have an idea. That's better.
Okay, well, we should be just about ready by now. Let's have a look and see what's happened. So we take our freshwater fish here and our saltwater fish here, and they're quite different from one another. I don't know if you can see it. This saltwater fish is definitely much smaller than the freshwater fish now, and it's squishier and kind of gross feeling. I don't know if you want to touch that. I wouldn't, but now that you do. So this one's softer.
It's like mushy and that one's not.
This one's firm. So this has confirmed what we expected to happen, is that because this freshwater fish is saltier than the water has moved in, and it got bigger and it got firm. Whereas here, the saltwater fish is less salty than the water around it. So the water's moved out and it's gotten all small and squishy and slimy.
So you think with all the fish in the ocean, they would drink it all. Here's another question.
How big is the ocean?
Let's see. Most of the Earth is covered by water. Ocean rhymes with potion. Circumference of the Earth equals 40,000 kilometers. Carry the sphere. Remainder. You're gonna make my head explode! I'm glad Adam is here to answer, because as far as I know, the ocean is ginormous big. Is that right, Adam?
That's right, it is pretty ginormous, and I can see it's hard to get your head around sometimes, given what you just went through, but I've got a picture here I brought that might help illustrate this. Have a look at this. And what we have here is...
The carpet.
Well, it's hard to tell what it is, but do you see this pale blue dot right here?
Oh, that thing?
That's the Earth.
What?
Yep, that's the Earth taken from 6 billion kilometers away. And from that distance, we call it the pale blue dot. Well, because it's a pale blue dot. But why do you think that is? Because of the water.
Oh, okay.
Right. So even when we look at the Earth from a little bit closer, like here, you start to recognize it a bit more.
Yeah.
And we call it the blue planet from this distance, but you can really see the oceans here. And you can even see that there's another form of water on the Earth, and you can see the clouds, right? And they're made of water too. So when you look at it on this level, you can really see that there's more than twice as much water than there is land on Earth.
Wow.
So there's a lot.
The ocean is so big that if we divided it up into swimming pools, then it would be enough water for everyone on Earth to have 75,000 pools each. Sweet, right?
I'd tell you how many toilets it equals, but it's in the quadrillions, and you don't want to think about diving into that. Here's another question.
Why does water make stuff float?
So we know that rocks sink and feathers float, but what about huge ships? They float, and it's a good thing they do, because they transport things all around the world for us. So why do things float, Adam?
Yeah, well, that's a really good question. And to help illustrate the answer, I'm going to use these two familiar objects. Relatively similar in size, even though one is a bit bigger than the other. We have our lemon and the citrus cousin, the lime. So what I'm going to do, put the lemon in the water, what happens?
It floats.
It floats. So we're going to put the smaller one in, and what do you expect to happen?
It should float, or not.
But it doesn't. So what's happening here? Well, the answer lies in the word called density. These objects are different densities, which essentially means that they have different amounts of air inside them. So in an object that has more air inside of it, it'll be less dense, and so it'll float. And so the opposite being that if it has less air inside, it's more dense, and then what happens?
It sinks like the lime. Who knew? Well, I guess you did because you just showed me. But I think we should put all this to the test in... My Great Challenge! Today, my great challengers are Cameron and Benji. Woo! Okay, today your great challenge is to take a ball of plasticine like this and try to make it float. Another thing you have to do is once you have it floating is to get it from one end of the pool to the other without using your hands. But you have these fans to help you.
Can we make the ball of plasticine any shape we want?
Well, yeah, actually, whatever floats your boat.
Okay, are you ready?
Yeah!
Get set, go!
Benji's flattening his plasticine, and Cameron's making his round.
Give it a shot.
It looks like Cameron's plans were sunk.
So that one didn't work.
Are they getting the right idea here?
Well, it looks like they're on the right track. Remember we were talking about the limes before and the lemons, and that was sort of a question of buoyancy and how much air is inside? Well, this is a bit of a different situation. It's more like the object and the water are pushing against each other. So what you want to do is you want to have like a push of war rather than a tug of war, and you want the water to win, so to push it up to the surface. And,
Sunk right.
Getting there, I think, though. I guess as well, you want the water to stay under the plasticine and not to get on top of it, too. That would make a big difference.
Cameron, trying again. Watch out for the Kraken. Benji, testing out his plasticine.
Maybe you could think like a boat or a canoe, right? Because they have edges that come up so that the water doesn't come in as well.
Of course, you can't have holes in your boat either.
Yeah, well, that's right.
That's what I'm working on.
So why do you think they're having such a hard time getting their plasticine to float?
Well, I think one of the reasons is because you chose a very difficult challenge today, but really I think it's a question of making sure that the weight of the boat spreads itself out as much as possible over the surface of the water, and that's really tricky to do. That's a nice flat pancake.
Yeah.
Place it really gently.
Oops. This water got on top of it, right?
That's right. Okay, we're back to the canoe form over here. If you can try and make a lily pad here,
maybe
that might be a good strategy. And you're gonna have to put that in the water really carefully, though.
Looks like a pan almost.
Looks
I
like
think
a
he's
raft.
getting really close there. Let's see.
And it floats.
Oh, he has it.
Look at it go!
No.
Cameron's boat floats because it weighs less than the water it pushes out of the way.
Looks like the lily pad was successful.
Looks like Cameron's our winner.
Yes.
Congratulations.
Right.
Uh-oh. Do try this at home.
Okay, so here's an experiment you can do at home. All you have to have is 2 glasses of fresh tap water. Then, with one of the glasses of the fresh tap water, put some salt in it and stir it up. And now, since salt water is more buoyant than fresh water, you take some eggs, you put the egg in the fresh water, it sinks, and in the salt water, it floats. Now it's time for another question. This one's from James.
What's the deepest anyone has ever gone into an abyss?
James, I looked up what an abyss actually is, and it turns out it's a really deep pit in the ocean. It's so deep, they gave it a really deep name. It's called Challenger Deep.
If you took the tallest mountain on Earth, Mount Everest, and threw it into Challenger Deep, it would still be covered by like 3 Eiffel Towers of water.
Oh.
The deepest anyone has ever gone is when 2 guys went to the bottom of Challenger Deep. Did you ever dive down deep in a pool and your head started to feel squeezed? That's pressure from all the water above you. In the deep ocean, the pressure is so strong, we need to go down in submarines or our heads would implode.
That means it gets smaller. Like this. Check out these weird creatures that live down there, but don't implode.
These fish have to have some pretty cool adaptations to survive there. That means their bodies have changed to allow them to live down there.
Because it's dark, some of them have bigger eyes,
or can even make their own light. They're totally freaky looking.
But not as scary as this next question from David.
Why do sharks die if they stop moving?
Sharks? They're scary, especially with this music. So to find out the answer to your question, David, I'm gonna meet one. I'm so scared.
But at least I didn't actually have to swim with one, like marine specialist Nicole Can does all the time at the aquarium.
So Nicole, what are you gonna do today?
I'm gonna go for a swim with these sharks.
But they're sharks!
Well, yeah, they're not as scary as everybody thinks they are. What is the scariest part of their body to you, Harrison?
Well, they're sharks and they have big teeth and they'll eat you and they're gonna hurt you.
Okay, let's talk about the teeth for a second. Granted, sharks have some pretty impressive chompers, but they used to be a lot bigger. Do you want to see a tooth?
Sure.
Okay. This is actually a mold of the biggest shark's tooth we've ever found. It's about as big as your head.
It is as big as my head, pretty much.
And this was called the megatooth shark, but it's been extinct for a really long time. Nowadays, they have much smaller teeth. In fact, this is a real black-tip reef shark tooth from the sharks I'm gonna go swimming with.
So small.
Yeah. And it's perfectly designed for eating fish, not people.
That's good. So let's answer David's question. Do sharks die if they stop moving?
Some of them could. The black-tip reef sharks in here, the big ones, if they stop moving, they're not passing water over their gills, so they're not getting any oxygen. Basically, they stop breathing. But some sharks can actually do all of that and pass that water over their gills even while they're staying still, so they can hang out at the bottom and have a little bit of a rest.
But they're still really scary. What if they come to my house and eat me?
They're not gonna do that. Are you a sick or dying fish?
Definitely not.
Then they're not gonna eat you. These are top predators out in the ocean, but they have a really important job to do in their ecosystem. They eat the sick, the injured, or the dying prey items. And by doing that, they actually help clean those animals out so they don't spread their diseases to the rest of the population. In fact, they're keeping fish populations really healthy in the ocean.
Well, then I'm not getting sick. I'm gonna go take some vitamins and eat some broccoli.
All right, and I'm gonna go for a swim.
Oh, well then, I'll save the broccoli for later.
Good luck, Nicole, but don't say I didn't warn you. So So Nicole told me that sharks are at the top of the food chain in the ocean, but there's something at the bottom of the food chain that Nicole says is only about this big, but it's just as important. Phytoplankton. And this phytoplankton stuff is a pretty big deal too. There are more than 5,000 species of it. Look at these. You know what's amazing? Phytoplankton produce half the oxygen for the whole world.
Here's a question from Angelina.
What do oceans do?
You mean like on the weekend, or do you mean why is it there? I think the question is, what doesn't it do?
It's a highway for us to transport stuff around the world. It gives us food to eat and rainwater for us to drink and use to grow crops. We need the ocean to survive, and it's home to more species than we can even count.
Let me catch my breath, and then I'll be able to answer the question that you've all been waiting for.
Are sea monsters real?
Well, Vito, the big answer is, I'm gonna show you one. There's no real proof that sea or lake monsters like the Loch Ness Monster exist.
And the Kraken was probably just a giant squid. But just because those monsters aren't real, it doesn't make the ocean safe.
But there is something really scary in the ocean, and I'm about to reveal what it is right now.
There's a monster in the sea. Away, yo! There's a monster in the sea.
You better not go.
It's spreading oil on the waves
for 20,000 leagues.
And garbage in the deep.
Davy Jones low.
It's got billions of teeth
and billions of arms.
It's eating all the fish and it's causing lots of harm. But it doesn't look like these creepy beasts.
'Cause the monster in the sea is you and me.
'Cause the monster in the sea is you and me.
Yes, the monster in the sea is you and me.
For a long time, humans have used the ocean as a bottomless supermarket and garbage dump. Not a good combination.
Experts say that 1 out of every 4 species of fish is being caught faster than it can reproduce and make new fish.
Fortunately, a lot of people, including kids, are realizing that we need to be careful with the ocean. We need to protect it if we want it and us to stay healthy and monster-free. And if we want a place to surf. Thanks for helping me find stuff out. Gotta go hang 10. Surf's up! Woo!